welcome to the today's class. So in previous class we have discussed about the register organization. So we have seen the functions of 13 registers. Now we will discuss about the flags register. This flag register 8086 is having total 9 flags. Flag register will store the flags. Total 9 flags are there in 8086, and all these flags are being classified into two groups: conditional and control. So conditional flags is also called as status flags. So these conditional flags will they will be used as condition for certain operations. When we are performing any operations, then these flags can be used as a condition. Based on the condition, generally the jump instruction, their conditions are used along with the jump instructions. So for that purpose, these conditional flags, that is why the name conditional flags are being given, as they are being used as conditions for certain operations. And the other name for the same flags is status flags, means these flags are going to indicate the status of the result. So it is going to indicate the status of the result, that is why the other name status flags also given to this. Okay, total 6 conditional or status flags are present in the 8086, and control flags. So these flags are going to control the behavior of 8086. The 8086 performance is being controlled by these flags, so the name control flags are being given to this. There are total 6 control flags are there. So 3 control flags are there and 6 status flags. So the status flags are carry flag, parity flag, auxiliary carry flag, zero flag, sign flag, and overflow flag. These are the 6 conditional or status flags, and 3 control flags: trap flag, interrupt flag, and directional flag. These are the 3 control flags. So we'll discuss about these flags one by one. So this is the organization of the flags register. So these are the 9 flags. So first, carry flag, parity flag, auxiliary carry, zero flag, sign flag, trap flag, interrupt flag, direction flag, and overflow flag. So here the carry flag, parity flag, auxiliary carry, zero, sign, and overflow flags comes under the conditional or status flags category, and trap flag, so interrupt flag and direction flag comes under the control flags. We'll see one by one. First, carry flag. So when 8086 is performing any arithmetic operations, especially addition and subtraction, so the carry flag is going to be updated as per the result. So during the addition, if there is a carry generated from MSB, then carry flag will be set. So during the addition, if there is a carry out from the MSB, then carry flag will be set. That indicates there is a carry generated from the MSB during the addition operation. Then during the subtraction operation, if there is a borrow into MSB, that means when we are trying to subtract higher value from the lower value, then a borrow is needed into MSB. During that time, so the carry flag will be set. So here the carry flag is going to indicate during the addition when there is a carry out from MSB, or during the subtraction there is a borrow into MSB. for that the carry flag will be set. The second is parity flag. The parity flag indicates the number of ones present in the result. So if the result is having even number of ones, that is being indication in the parity flag. The parity flag is set 1 means, so the result is having even number of ones. That is the indication of parity flag. An auxiliary carry flag. This auxiliary carry flag is used especially for BCD operations, binary coded decimal. So every decimal digit is being encoded in a 4-bit binary, that is BCD. So for BCD operations during BCD addition and BCD subtraction, so this auxiliary carry flag is being used. During the BCD addition, if there is a carry out, from lower nibble to upper nibble, okay, so that is from 3rd bit to 4th bit. Bit 0, 1, 2, 3 belongs to lower nibble, bit 4, 5, 6, 7 belongs to upper nibble. If there is a carry out from bit number 3 to bit number 4, then auxiliary carry flag will be set during the BCD addition. And during the BCD subtraction, if there is a borrow from upper nibble to lower nibble, that is if there is a borrow from bit number 4 to bit number 3, then auxiliary carry flag will be set. That is the use of auxiliary carry flag. Then zero flag. If the result is 0 after performing any operation, if the result is 0, then zero flag will be set. If zero flag is set means the result is 0. So whatever operation is being performed, if the result is 0, zero flag will be set. Otherwise, if the result is non-zero, then zero flag will be reset. That is about the zero flag. And sign flag, and if the result is a negative, then sign flag will be set. Okay, if the sign flag is set means whatever result we are getting is a negative result. If the result is positive, then sign flag will be reset. Okay, so positive result. If the result is positive, then sign flag is reset. If the result is negative, the sign flag is set. And overflow flag. So this overflow flag is used to indicate the status again, whether the result is exceeding the capacity of the register, that is equal to overflow. So mainly this is being used mostly in arithmetic shift left, okay, so mostly it is used in arithmetic shift left. When arithmetic shift left is being performed, then sometimes a positive number may becomes negative, a negative number may becomes positive, so that will be indicated as overflow. After performing arithmetic shifting, suppose so we have a data like this. For example, if this is the data, if you have to perform the arithmetic shift left, so then after performing the arithmetic shift left, so it is going to be 1 1 1 0 0 0 0 1, sorry 1 0. LSB is filled with 0 and all the bits are shifted left. If this is being performed, see, before shifting the value is positive, but after shifting the value becomes negative. Now this kind of status is being indicated as overflow. Okay, so that is where the overflow flag is used for the arithmetic shift left operations. So here positive becomes negative, and maybe sometimes negative may become positive again. So that is being indicated with overflow flag. So all these whatever we have discussed, that is carry flag, parity flag, auxiliary carry, zero, sign and overflow, all these are indicating the status of the result, whether there is a carry out during the addition or whether there is a carry out during the BCD operations from the lower nibble to upper nibble, okay, or whether there is even number of ones in the result, or if the result is 0 or if the result is non-zero, when there is an exceeding the result capacity of the register, or if it is arithmetic shift left, so positive become negative or negative become positive, all these things will be indicated the status of the result. So these flags are called status flags or condition flags because these can be used as condition. See, if there is overflow, do something, otherwise do other thing. Likewise, so jump on carry, do it, or jump on no carry, that is carry flag is used as a condition. So jump on even parity, jump on odd parity, then okay, then zero flag jump on zero, jump on no zero, then sign flag jump on minus, jump on positive, okay, jump on overflow, jump on non-overflow. Likewise, these flags are being used as conditional flags, so the name conditional flags are being given. Okay, so that is about the status or conditional flags. So total 6 are there in this group. Next is, so we will see the control flags. So in control flags, first is trap flag. So these control flags are going to used for controlling the processor. So if the trap flag is 1 or if the trap flag is set, then processor will be entering into the single step mode. Processor will be entering into single step mode. So that means every instruction execution, so processor registers are being verified for errors, that is mostly it is step by step debugging purpose it may be used. So trap flag is 1, that is trap flag. So that is the meaning of single step. So after every instruction execution, processor will stop to verify whether whatever process is being done, whether it is right or wrong. So all the registers also be cross checked whether the result is okay or not. So that is being used as a debugging purpose, step by step debugging purpose this flag is used. So that is trap flag. The second is interrupt flag. If interrupt flag is set, only then processor will service the interrupts if it receives. All maskable interrupts can be serviced by the processor if the interrupt flag is set. If the interrupt flag is reset and processor is not going to service any of the maskable interrupts even though they are set. If processor receives any maskable interrupts, processor will not going to respond to them if the interrupt flag is reset. So that is the important, means whether processor has to service the interrupt or should not be service the interrupt will be decided by the interrupt flag. Then the third one is the directional flag. If the directional flag is reset, then the string operations will be performed in ascending order. All the string operations will be in ascending order. And if the direction flag is reset, all the string operations will be performed in the descending order. So that means from highest address to the lowest address, all the string operations will be performed if the direction flag is set. And if the direction flag is reset, the string operations will be performed in ascending order, that is lower address to higher address. So address will be incremented automatically if the direction flag is reset and processor is performing the string operations. Automatically the memory pointer will be incremented with every operation. So auto increment, auto decrement feature is used with the direction flag for string operations. So that is about the control flags. So these three flags are controlling the behavior of the processor. That is why these flags are going to be called as control flags. And the status flags, they are going to give the status of the result, or they can be used as conditions for certain operations. So this is about the flags register part. So today we will stop at this point. So we will continue in next class with the architecture of the processor in the next class.